To start off with word problems, I'm going to show you something that I use in parties, and people think it's magic. And part of what word problems are is to try and interpret what the words are and then perform the appropriate actions and do the analysis. Now let's take a look at this. It says start with any number you like. Add to this number the number that is 1 greater than the first number. And that's the part that people have trouble. What is 1 bigger? Add 7 to this sum, divide by 2, subtract the number you started with, and verify that your result is 4. Hang on, we're starting with any number and we're going to end up with 4? How does that work? Well, let me show you. And what we're going to do is we're going to do a couple of examples to show that this indeed does work. And then at the end of the video, I'm going to show you why it works using algebra. And I'll even show you how to make it come up with not just 4, but any number you like. Okay, for the purposes, let's start with just the number 5, okay? So it says take any number, so let's say 5. It says add the number that's 1 bigger than this. So let's add 6. That gives us 11. Then it says let's add 7. That gives us 18. And then it says divide by 2, which gives us 9. And subtract the number you started with, and oh my god, we got 4. Huh. Let's start with another number. Let's pick 7. And it says add the next number highest to that. So let's say 7 plus 1 higher than that is 8. That gives us 15. Then it says add 7. That's going to give us 22. Then divide by 2, which is 11. And subtract the number you started with. Oh my god, it's 4 again. So you can do this with any number you like. Take that number, add the next number highest to it, add 7, divide by 2, subtract the number you started with, and you'll always end up with 4. Now, as I said, at the end of the video, I'll show you an analysis of this using algebra so you can sort of figure it out and why this happens. We'll even show you how to make it come to any number, not just 4, but any number you choose. And this is great in a party. You can ask one person at the party, say, pick a number, whisper in my ear, you do that, go through the procedure, and you're going to find that everybody that's done the math will come up with that number as well. And we'll show you how to do that at the end of the video. Now, one of the key issues in understanding word problems is to understand what it's asking for. So you have to locate the words and expressions that stand for mathematical operations. And we're going to apply this, as I said, to the thing that we start off with, that magic question. So they're going to have stuff like the difference of is equal to the quotient of. So when you say the difference of A and B, that means A minus B, or it could mean B minus A. If you say 4 less than, it means X minus 4. If you say 3 greater than, it means C plus 3. 3 greater than C is C plus 3. If you say the sum of X and 4 is equal to 3 times X, sum of X plus 4 is X plus 4. 3 times X is 3X. If you say 3 consecutive integers starting with X, that's X. And as we said before, we start with any number, we add the next number highest to it. And 3 consecutive would be X, X plus 1, X plus 2. And we're going to see this when we try solving that problem that we had at the start. Okay, part of what we have to do is identify the unknown. So it's going to have stuff like find, calculate, what is, how much, and so on. And so usually what we do is we let the unknown equal some variable. Most times you use X, but as we saw before, we can use P or whatever. There was a whole section in the text about percentage. And we're going to simplify this down to just what you need for word problems. If we say 76%, the idea of percent means per 100. So 76% is really the fraction 76 over 100. And if you write this as a decimal, that's 0.76. So as long as the number that you have here is less than 100, then this is going to be less than 1. Or sometimes it'll say there was 150% profit, which means that's 150 over 100, which is equal to 1.5. So percentages, if they're less than 100, will be point something. If they're greater than 100, it's just going to be whatever this is divided by 100, and that's just going to shift the decimal place, as you can see here. Let's look at example 19 here. A word problem may have something like, find two numbers whose sum is 80. So what you're going to need is two variables. For instance, x will be the first number, y will be the second number. Because they're two different numbers, you need two different variables. So in this case, you know that x plus y, because it said sum of, is equal to 80. And this is the formula that you would come up with based on that. Now you can always rewrite this in terms of y equals or x equals. And in this way, you will be able to, if you figure out what x is, then you can substitute in what x is, and then you can figure out what y is. So you have a relationship here that you can work with. Let's take a look at example 20. A person invests part of his $10,000 savings in a bank at 6% and the remainder at 8%. What that means is we can set some variable to say let x equal the amount at 6%. And then from this, you can actually say, okay, well, how much was the total? I had a total of $10,000, and if I subtract x from that, which is the amount at 6%, that's the amount that I have at 8%. So you have to sort of think this stuff through. Or you could say let x equal the amount invested at 8%. Then 1,000 minus x is the amount invested at 6%. Part of problem solving word problems is to make sure that you have a rough idea what the answer should come out to be. Because if it's completely different, then you know probably the process is not correct. The hardest part of doing word problems is to take the words and turn them into equations. Because if you don't have an equation, you can't solve, so you have to be able to interpret what the words are saying, turn it into an equation with various variables in order to be successful. Once you've taken the words, turned them into equations, and solved the equations, one of the things you have to do is check your answer. Does it make sense? Is it reasonable? So if you do some sort of calculation with an automobile and you come up with an answer like 600 kilometers per hour, I don't think that makes sense. You calculate somebody's age to be 150 years. Does that make sense? So you have to make sure that whatever you've done, the results make sense, because then you have to start again because you've definitely done something wrong. Now another problem with word problems is to make sure that your answer meets all of the conditions set out in the problem. For instance, example 25 here says a problem asks for 3 consecutive odd integers whose sum is 39. Now we can see here, if we look at this possible solution, 12, 13, and 14 are consecutive integers whose sum is 39, but they're not all odd. 13, 15, and 17 are all consecutive odd integers, but their sum is not 39. 9, 11, and 19 are odd integers whose sum is 39, but they're not consecutive. So 11, 13, and 15 are consecutive odd integers whose sum is 39, and therefore D would be the proper response. Now the hardest part, as I said, is to turn what's in the problem into proper relationships using variables. So let's take a look at example 26 here. It says if twice a certain number, we let the certain number be x, and we say twice a certain number, is increased by 9, that's plus 9. And the result is equal to 2 less than triple the number. There's triple a number and 2 less. Now let's put the value back in just as we were talking about before with a lot of these things that we did earlier. Twice a certain number. So twice the certain number, if it's 11, times 2 is 22. Is increased by 9, so let's add 9, so that's 31. So that's our left side. Then triple a number, so if we 33 and we subtract 2, we get 31. So these two are identical, and therefore our solution does work. Now we've already seen example 27 in a way. All we did was we were given 4 different solutions, and we had to make sure they fit all the criteria. And it says find 3 consecutive odd numbers whose sum is 39. So this is going to go through the solution of how they came up with the appropriate answers. And let's see if we can figure this out. So we're going to let the first odd number be x. So if that number happens to be, say, 3, I'm not sure what the number is, but the next odd number is going to be 2 bigger, which is 5. So we'd have 3, 5, and then 5 plus 2 is 7, and so on. So once we figure out this is our first odd number, each odd number after that is going to be 2 greater. So what we have here is x, which is our original number, x plus 2, which is our next odd number, and x plus 4, which is going to be like 3 plus 4, is going to give us our third number here. So this is going to be our equation. So that's first odd number, second odd number, third odd number, and that's what it equals to. This is how we're going to set it up to solve this problem. So if we do this, we have x plus x plus x, which is 3x. We have 2 plus 4, which is 6. And on the right-hand side, we have 39. So this works out to be 3x is equal to 33. X is equal to 11. That's our first number. So that means that our number should be 11, 13, and 15. And if we add these three numbers together as a quick check, this is going to give us indeed 39, and these are consecutive odd numbers, so everything is correct, and that is going to be our answer. Now example 28 is not an easy question to do, but you have to be able to read through this, and it says in a group of 102 employees. So that is the total number of employees. And it says there are 3 times as many employees on the day shift as on the night shift. And it says there's 2 more employees on the swing shift than there is on the night shift. So let's start with the night shift as being our base. Let x equal the number of employees on the night shift. And what do we know about the day shift? There's 3 times as many. So the night shift times 3 will give you the number on the day shift. Now it also says there are 2 more employees on the swing shift than there are on the night shift. So the night shift is given by x, so this is just going to be x plus 2. So what we see is this is our night shift, our day shift, our swing shift. All of these have to add up to the total here of 102 employees. So this is how many we have on our night shift. And as it said, their day shift has 3 times as many as the night shift. And the swing shift has 2 more than the night shift. Here's the number here for the day shift. This is the swing shift. This is the night shift. When you add all these up, you're going to get 102. So if we solve this, this is going to be 3x plus x plus x. That's 5x plus 2 equals 102. So 5x is going to be 100, and x is going to be 20. Then we know that there's 20 here. 3 times that, there's going to be 60 here. And x plus 2, that's going to be 22 here. Now if we add all these up, we should end up getting 102, and I think you see that yes, indeed, it does work. We've taken care of all the conditions in the problem that we have here. Okay, now we said at the start, we want to take a look at this magic problem. We saw that any number we start with and do all these calculations, we end up with 4. Let's see how this happens. It says start with any number, so let's let x be any number. And it says step 2, add to this the number that is 1 greater. Well, the 1 greater than x is going to be x plus 1. Because if this is our number we start with, x plus 1 is 1 bigger than that. Then it says add 7 to this, divide by 2, and subtract the number you started with. So if we look at the top, that's 2x plus 8 over 2 subtract x. If we divide through, 2 goes into this once, 2 goes into this 4. So this is x plus 4 subtract x. And what do we have? X minus x, we get 4. It doesn't matter what number you start with, you're always going to end up with the number 4 because you're subtracting the number you started with. Now, as I said at the start also, I can make it come up to any number other than 4. You can pick any number you like. Now, this add 7 is the critical one here, and that's what's going to give us 4. Because if we want it to add up to 4, if we multiply 2 times 4 and subtract 1, that's going to give us a 7. And that's how we figure out what number we need to make it come to 4. So we just double this number, subtract 1, and we get 7. So let's validate that because I've said that, but let's take a look and see if we want to make it come to a different number. Let's just say we want it to come to 7. So the calculation here is going to be 2 times 7, which is 14, minus 1. So that's 13. So what we have to do now is just go up here and change our 7. So if you remember how this works, we take any number, add the next number highest, and now this time we're adding 13, and then we're going to divide by 2, and we're going to subtract the number we started with. So this is going to be 2x plus 14 over 2 minus the number you started with. So this is the same thing if we divide out the 2's again, and this, we're going to get x plus 7 minus the number we started with, which is x, and therefore we're going to end up with 7.